In this example, we are going to use mesh analysis to find V0. In mesh analysis, the first step is always to define mesh currents. Sometimes we use loop instead of mesh. So we can define this as my mesh current 1, this will be mesh current I2, and this is also mesh current I3. Step 2 is to write loop equations. And these loop equations are based on KVL or Kirchhoff voltage law. In the first mesh, we will follow the clockwise direction to write the equation. So the voltage drop on this 1K resistor, that is a 1K times current I1 minus I3. The voltage drop on this 1K resistor, that is a 1K times I1 minus I2. Then there will be another voltage increase of 12, so minus 12, that is equal to 0. The loop equation for the second mesh, that is the increase of negative 6 plus 2K times I2 plus 1K times I2 minus I1, that is equal to 0. The third mesh equation, that is, let's start from this 1K resistor, so that is 1K times I3 plus 6 plus 1K times I3 minus I1, that is equal to 0. The third step is to solve the equations. We can find I1, that is equal to 66 over 7 milliamp, I2, that is equal to 36 over 7 milliamp, and I3, that is 12 over 7 milliamp. And step 4 is to get the conclusion. In this problem, we look for V0. V0 can be obtained by using Ohm's law. So V0, that is equal to I2 minus I1 times the resistance of the resistor, that is 1K. So that gives us negative 4.29 volts. If we look at the problem again, we also notice that this is a circuit with only independent voltage sources. It implies that we can do model by inspection. Since we have 3 unknowns, so eventually it will lead to a matrix form with a 3 by 3 matrix times the vector with the 3 unknowns, I1, I2, and I3. And on the right hand side are the increase of the voltage sources. So in mesh 1, we have a voltage increase of 12 volts, and for mesh follow the direction of the current, we have a voltage increase of 6. And for mesh 3, follow the direction of I3, there's a voltage decrease of 6, so we have negative 6. Then the left is this matrix. In this matrix, the diagonal entities are simply the summation of the resistance of all the resistors in the current loop. So in mesh 1, we have 2 resistors in the mesh, which is a 1K and another 1K. So the 1 plus 1 here. For the second mesh, we have 2 plus 1. And the third mesh, we have 1 plus 1. The off-diagonal entities are the shared resistance between the meshes with a negative sign. Between mesh 1 and 2, there's a resistor that is shared, which is 1K, so a negative 1 over here. And between 1 and 3, there is a shared resistance of this 1K, so that is a negative 1. Between 2 and 3, there's no shared resistors, so we have 0. And since matrix is symmetric, so we can also get the other entities, this negative 1, and 0. Then we can solve this equation. We can get I1, I2, I3. So if you do it correctly, you should get the same answer. I1, that is equal to 66 over 7. I2, that is equal to 36 over 7 milliamp. And I3, that is equal to 12 over 7 milliamp. You can draw the conclusion, say V0 that is equal to I2 minus I1 time is 1K. That will give you negative 4.29 volts.